Now come to this point, acceleration of the freely falling bodies. Whenever we uh, uh, leave a body from a certain height, for example, if this is a building, I am showing a building, and a stone is dropped from this height of the building, then this stone will fall freely. Remember this, that we are not considering the air resistance. We are neglecting the air resistance. So whenever a heavy body or lighter body are thrown without the air resistance, remember that their acceleration will be the same. That acceleration will be the acceleration of the freely falling bodies, or that is also called acceleration due to gravity. Acceleration due to gravity. Remember this, that whenever we are considering the acceleration due to gravity, we have to consider that there is no air resistance. In this chapter, we are not considering the air resistance, but when we will be discussing dynamics, the next topic after this, in that case, inshallah, we'll discuss the air resistance also. But here, I'm just going to give you the brief idea of the acceleration due to gravity, because the body is falling in a gravitational field. And I think so you might be aware of the gravitational field, that you know that earth is a massive body. Earth attracts any body towards its center. It is pulling every body towards itself, and that pull causes a body to accelerate. Whenever you are throwing the body from a certain height, its velocity increases at a constant rate. For example, let us have an example. If I ask you to jump from a table, you can jump very easily from the table. What is the reason? Because the height between the table, this is the table and this is the floor, this height may be 1 meter, this may be 1 meter, and 1 meter is a very small height, so you can very easily jump from this table. It means your velocity will not increase too much to hurt you or to hit you hard with the ground. But if I ask you to jump from a 10-meter high building, then it will not be possible for you, and without hurting yourself, you cannot do so. What is the reason? Because when you start jumping from a higher point, then your velocity gradually increases. That increase in velocity, which is constant in the case of acceleration due to gravity, and that acceleration due to gravity, which is constant, causes you to increase your velocity. When you reach at this lowest point, you will hit with that velocity, which will be reached due to the gravitational pull of the earth. Now, acceleration due to gravity is a constant quantity normally. It ranges from 9.8 meter per second square to 10 meter per second square. Due to the different radius of Earth at equators and poles, this difference occurs, because equatorial radius is different than the polar radius of the earth. So this difference may occur due to this unequal radius of the earth. As you know that earth is not a complete sphere like a football, but it is something like egg or oval type, etc. Okay, well, so remember this, whenever we are talking about acceleration due to gravity or the acceleration of freely falling body, it may be taken as 9.8 meter per second square or 10 meter per second square. Normally, for the sake of calculations, we will take 10 meter per second square, because while taking 10 meter per second square, our calculations will be easier. We'll also do the experiment to find out the acceleration due to gravity at the place where we are conducting the experiment. Okay, I hope that you have understood that. Now let's remember one a very basic thing, that zero error is a different thing and experimental error is a different thing. So please don't confuse experimental error with the zero error. Zero error related to an instrument, like if I'm using this micrometer, so there may be a zero error in this micrometer. Now there may be an experimental error. For example, if this student is throwing a stone from a certain height and this student is noting the time when he is just dropping the stone. So this student may cause any error while starting the stopwatch, or when this stone strikes the ground, then while switching off the stopwatch, he may cause any error. His response, his response may not be very quick to measure the time. So this may be an experimental error. Okay, so I hope that you have understood that what is the experimental error and what is the zero error. Remember this thing, that zero error is related to the instrument and experimental error related to the person or the environment, etc. Okay, well, acceleration due to gravity can be calculated with a certain instrument. Now come to the topic again. I was telling you that the acceleration of the freely falling is 9.8 to 10 meter per second square. As I told you that acceleration due to gravity has this fixed value, and remember this velocity when you are dropping an object from a very high building, then it will reach to the ground, and during this interval of the time, or for this height, for example this height is 10 meter, initially its velocity was zero, initially its velocity v was zero, but when it will strike at the ground, its velocity will be different. For example, its velocity may have some different values. We are not aware, say its final velocity is x. So this change in velocity, if you will be able to calculate this velocity at this point, if you are able to calculate the velocity, I am talking about if you can find out the velocity when it hits the ground, then the difference of these two velocity divided by the time taken, because this student is calculating the time. So change in velocity divided by time gives you the acceleration. Remember this. And as this thing has already been calculated by the scientists many times, they have done this and they found that result comes between 9.8 meter per second square to 10 meter per second square. So normally in our numerical we use this 10 meter per second square. And but you remember this, that today inshallah I'll upload some few more worksheets or questions related to the past paper, and I hope that you will do those things which I'll upload. Okay, and I have also uploaded the solution of that worksheet which I did last time. Okay, I hope those who have done it, it's very good. Those who have not done, please do it regularly. It is for the sake of your practice. I'll upload the previous as well. Okay, let me take the attendance of the students also. Uh, Please upload the previous version. Okay, sir, please A previous worksheet will be uploaded on Edmodo, Muhammad Umar, inshallah. So from there you can take the previous worksheet. Okay. Well, now let me take your attendance. The homework for today will be uploaded inshallah on Edmodo. I'll give you a worksheet to solve, which you will have to solve. Okay. I am seeing that some students were present in the beginning, but they have left before the class overs. Please stay with me till the end of the class because I have to see that how many students are attending regularly and those who are not attending regularly, uh, I will have to see that why they are not attending. Okay. Okay. In the meanwhile, if you have any question, you can ask now. Sir, I emailed you what you emailed me. Okay, those who emailed me the work late, I have also explained them. Actually, in the worksheet which I uploaded last time, I did not mention this question, but uh, in the solution of the worksheet which I'll give you today, inshallah, today I'll also upload a link in which I have given the solution of this complete question. And there was also another question. This was also the second question, which I explained in the link. So please do watch. That link is about the kinematic worksheet 1. Okay. And today, inshallah, I'll upload a kinematic worksheet 2 in which